Good morning, children. Let's continue with exercise 3a. So in the last class we have done up to question number 3. So today we'll be continuing from question number 4. Answer true or false. The number of digits in the square number are always even. So the number of digits in a square number are always even. No. So which is false. There is no such property that number of digits in a square number, as we know 144, it is a square of 12, but it consists of 3 digits. So there is no such property which says that the square of a number is always even. The second, the square of a prime number is prime. So this is also false, as there is no such property. The square of a odd number is odd and the square of an even number is even. So that is one property like that, but there is no such property. So therefore this is false, as we know 2 is a prime number, but the square of 2 is 4, which is not a prime number. So therefore this is false. No square number is negative. Yes, no square number is negative. So this is the property which we have already studied. So this is the property number 6. A perfect square number is never negative. So therefore this is true. So the difference of two numbers is a square number. The difference of two square numbers is a square number? No. As we know, 9 is the square of 3, and as we know 9 is the square of 3 and 4 is the square of 2. So if the difference of these two is 5, so which is not a square number. So therefore this is false. Now 4000 is a square number? No, 4000 is not a square number. This is false, because the number of zeros at the end is odd. There are 3 zeros. So therefore this is false. So then question number 5. Just by looking at the following numbers, give reasons why they are not perfect squares. So Roman number 1, it is given that 2, 3, 6, 7. So it is not a perfect square because the unit digit is 7. As we know, according to the property number 1, that is, if the unit digit is 2, 3, 7 and 8, then these are not perfect squares. Okay, not perfect squares. So these are not perfect squares. So therefore, since here it ends with 7, so therefore this is not a perfect square. Again, it is not a perfect square because the number of zeros at the end is odd. 3 zeros are there. If even zeros, then it will be a perfect square, but as there is 3 zeros, so which is odd number of zeros, so therefore this is not a perfect square, which we have already studied in the property, that is property second, that is the number of zeros at the end of a perfect square is always even. But here we can see 3 zeros are there, that is odd number of zeros, so therefore this is not a perfect square. Again 35943, the end digit is, the digit in units place is 3, so therefore this is not a perfect square, as we already studied that 2, 3, 7, 8, if the number ends with this digit, this is not a perfect square. So here it ends with 3, so therefore this is not a perfect square. Again here we can see this ends with 8, so therefore this is not a perfect square. And again the last one, it ends with 2, so therefore this is not a perfect square. So let's move to question number 6. Question number 6, it is given that what will be the unit digit of the squares of the following number. If we square the following numbers, then what will be the unit digit of that number? So suppose the first one, which is 539. So if we square 539, that means for the unit digit, if we square, it becomes 9 square, because the unit digit is 9, so therefore it becomes 9 square, and the 9 square is 81. So therefore the unit digit is 1. In the final answer, the unit digit is 1. Therefore the unit digit is 1. Again for the second one, it is 731. If we square 731, that means 1 will be squared, the unit digit will be square, and if the unit digit is square, that is 1 square is 1. So therefore the unit digit is 1. Similarly, number third, it is 8593. So if we square 8593, the unit digit is 3, so therefore it becomes 3 square, and 3 square is 9. So therefore the unit digit in the final answer is 9. Again 23904, if we square this one, the unit digit is 4, so therefore it becomes 4 square, and 4 square is 16, so therefore the unit digit is 6, so therefore the unit digit is 6 in the final answer. Then let's move to question number 7. So question number 7, it is given fill in the blanks, use the property of the square number. So this is the property number 8, which is given the difference of the squares of two consecutive natural numbers is the sum of the natural numbers. So here the answer will be 37, that is 19 plus 18, 37. So here again the same property we have used here, that the difference of the square of two consecutive natural number is equals to sum of the numbers. So here it is 30 plus 29, so that is 30 plus 29, it is 59, 30 plus 29. So again here the last one, it will be 87 plus 86. So 87 plus 86, it will be 173, that is 87 plus 86, 173. So this is the answer. Then question number 8, without adding match the sum in a column A with a perfect square in column B. So this is one property is given, that the sum of the first n odd natural numbers is equals to n square. So this we have already discussed, this is the property number 7, the sum of first n odd natural numbers is equals to n square. So here in this question, the first, how many odd numbers are given? As you can see, 1, 3, 5, 7 and 9, that means 5 odd numbers are there. So the answer is 5 square. So 5 square it is 25, so therefore the answer will be C. As we know, according to the formula it is n square. So since according to the formula it is n square, according to the formula it is n square, according to the formula it is n square, and how many numbers are given? 1, 3, 5, 7, 9, 5 numbers are given, so therefore this is 5 square, that is 25. So the answer is 25, which is given in option C. Again 1, 2, 3, 4, 5, 6, 7, 8. Here this is the sum of the first 8 odd natural numbers, sum of the first 8 odd natural numbers. So therefore 8 square, so therefore the value of n will be, n square will be 8 square, this is 64. So 64 it is given in option D. 1, 3, 5, this is the sum of first 3 odd numbers, so therefore 3 square is equals to 9, that is E. Again this 1, 2, 3, 4, 5, 6, this is the sum of the first 6 odd natural numbers, 6 odd natural number, that is 6 square is equals to 36, it is given in option A. And the last one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 odd natural numbers are given. So 10 square is equals to 100. So this is given in option B. Now the next question, it is given that which of the following are triplets are Pythagorean. We need to check which of the following triplets are Pythagorean. So the first one, it is given that 10, 24 and 26. So here it is given 10, so which is in the form of twice m. So if we take the value of m as 5, then 2 into m it is 10. So therefore we must take the value of m as 5. So therefore we have taken let m is equals to 5. If m is equals to 5, then according to the formula twice m is equals to 10 and m square minus 1, that is m square, if m is 5 then m square is 25, 25 minus 1 is equals to 24. And m square plus 1, that is 25 plus 1 is equals to 26. So therefore it is, when it is 10, the second and third number is 24 and 26. So therefore 10, 24, 26 is a Pythagorean triplet. As we have found, if we take twice m as 10, then m square minus 1 becomes 24 and m square plus 1 becomes 26, which is already given in the question. So therefore this is a Pythagorean triplet. So this formula we have already discussed earlier in the property number 9. So for any natural number m greater than 1, twice m minus m square minus 1 comma m square plus 1 is a Pythagorean triplet. This we have already discussed, that when we are asked to check whether the following numbers are Pythagorean triplet, then we must see whether this is obeying, the given numbers are obeying this formula. If they are obeying this formula, So that means the values are according to this formula, then it will be a Pythagorean triplet. Again for the second question, it is given that 14, 48, 50. So here it is given 14. So if we take as twice m, that means the value of m we must take as 7. Then it will become 2 into 7 is equals to 14. So therefore let's take m as 7. If let m is equals to 7, therefore twice m is equals to 14. Again m square minus 1 is equals to, that is 7 square, which is 49 minus 1 equals 48. Again m square plus 1, which is 49 plus 1 is equals to 50. So therefore if the first number is 14, the second and the third number is 48 and 50, which is already given, 48 and 50. So 14, 48, 50 is a Pythagorean triplet. Similarly you can do the rest, that is question number 3 and 4. If these given numbers are obeying this formula, that is twice m, m square minus 1, m square plus 1, then they will be a Pythagorean triplet. If they are not following the formula, then they are not Pythagorean triplet. Then the next question is question number 10. So which of the number is not a perfect square? Now 64, it is the square of 8. 169, it is the square of 13. 288, so this is not a perfect square, so the option is C. So 400, this is a square of 20. Now the smallest number by which 890 must be multiplied so that the product is a perfect square. So let's do the prime factorization of 980. So 980, so if we do the prime factorization, it becomes 2 into 2 into 5 into 7 into 7. So if we make it pair, 2, 2, again 7 into 7, 5 remains alone. So therefore we need to multiply 5 with this in order to make 980 a perfect square, because 5 is alone. So therefore we need to multiply 5, so to make it as a pair, and then 980 will become a perfect square. So therefore the number to be multiplied with 980 to make it a perfect square is 5. So the answer is 5. So the answer is 5, which is given in option B. And the last question, that is 12. For every natural number n square minus n plus 1 whole square minus n square equals. So this is the property number 8, which is that the difference of the square of two consecutive natural numbers is equals to sum of the natural numbers, as we have already discussed earlier. That is, for every natural number, the difference of the squares of two consecutive natural numbers is equals to their sum, that is n plus 1 plus n. So therefore the answer is n plus 1 plus n. So the option is D. So that's all for today. So remaining we'll discuss in the next class. Thank you.